Welcome to Tanu Science. In this video, we'll learn the problems in chapter 4 of class 10. First question, numerical problems, book back. First one, an electric ion consumes energy at the rate of 420 watt when heating is at the maximum rate and 180 watt when heating is at the minimum rate. So here maximum rate, this is minimum. Maximum heat, maximum rate means to produce a high heat that electric ion consumes energy 420 watt. So 420 watt represents power in the first case. Next, that same iron box or electric ion consumes 180 watt power to produce a low heat. So now power is P2. So in the previous case power is P1. In the second case power is 180 watt. So there are two cases. Applied voltage in the both the cases 220 volt is always constant. Now, what is the current in each case? So current in each case in the sense at the maximum rate, at the minimum rate. So first we will calculate for the this maximum rate, and the another one is the minimum rate. Power basic formula P is equal to VI. We know that. So current we have to find out according to this question. So I is equal to P by V. Now in this maximum rate, I1 is equal to P1 by V. The minimum rate I2 is equal to P2 by V. I1 is equal to where P1. So P1 value we know that 420 watt. So 420 divided by volt, in both the cases 220. If we cancel 2 2s are 4, 1 2s are 2, 11 2s are 22. So I1 is equal, if we simplify this, we'll get 1.9 ampere. I2, for I2, P2 value is 180 watt. 180 divided by 220. If we simplify, we'll get 9 2s are 18, 11 2s are 20. So 9 by 11. If we simplify this, I2 value 0.8 ampere. So at the maximum rate, current consumes larger than in the minimum rate. Question number 2. A 100 watt electric bulb is used for 5 hours daily and 4 60 watt bulbs are used for 5 hours daily. So 100 watt electric bulb used 5 hours, then 4 60 watt bulbs also used for 5 hours daily. Calculate the energy consumed in kilowatt hour in the month of January. So in the month of January, the number of days is 31. So 100 watt electric bulb and 4 60 watt electric bulb. So first we have to find out the total power consumed. P1, this one you can take as P1 100 watt. The 60 watt is take as P2. So P1 is equal to 100 watt. Then P2 is equal to 460 watt. So 4 into 60 watt. If this 100 watt we have to convert into kilowatt because the energy consumed this by this appliance should be in the kilowatt hour. They are given in the question watt. So we have to convert into kilowatt. Divided by 1000 means we'll get 0.1 kilowatt. Then 4 6 are 24, 240. So if you divide by 1000, 0.24 kilowatt. Then total power, if you add these two, 0.34 kilowatt. This is total power. Now energy consumed by these bulbs per day. So energy consumed by these bulbs per day is equal to, so energy formula power into time. So power is 0.34 kilowatt. Then T time 5 hours. Given question itself 5 hours. This 100 watt bulb used for 5 hours. Then 4 60 watt bulbs are also used for 5 hours. So the time will be 5 hour. And if you multiply these two, we will get 1.7 kilowatt hour. This is energy consumed by this bulb in per day. But in the question they are asking energy consumed in the month of January. So in the month of January, 31 days. So total energy consumed in the January month, we are going to multiply with 31 days into 31. If we multiply this, 52 0.7 kilowatt hour is energy consumed by these bulbs in the month of January. So this is the answer. Question number 3. A torch bulb is rated at 3 volt and 600 milliampere. Calculate its power, resistance, then energy consumed if it is used for 4 hours. So first we can calculate the power. The given in the question voltage V and current I. Two datas are given in the question. Now we are going to find out the power. So power formula P is equal to VI, product of voltage and current. Now P is equal to V is 3 volt 3 into I. I is 600 milliampere. 600 into milli 10 power minus 3. So P is equal to 6 3s are 18 and 0 into 10 power minus 3. If we simplify this, power is equal to 1.8 watt. Next, resistance. Resistance formula R is equal to V by I, where V is 3 volt. So 3. I value 600 milliampere. 600 into milli 10 power minus 3. If we cancel this, we will get 200. This 10 power minus 3 goes to numerator. It becomes 10 power plus 3 divided by 200 is equal to 10 power 3 is 1000. 1000 by 200. So if we cancel this, we will get 5. So resistance is 5 ohm. Next one, energy consumed if it is used for 4 hours. So energy formula in terms of power and time, E is equal to P into T. E is equal to power. Already we have calculated 1.8 watt. So 1.8 into time is 4 hour. Unit of power is watt. Unit of time is hour. Watt hour. So E is equal to, if you multiply this to 7.2 watt hour. Question number 4. A piece of wire having resistance R is cut into 5 equal parts. How will the resistance of each part of the wire change compare with the original resistance? Now piece of wire having resistance R. So let us consider this is piece of wire. Its resistance is R, which is cut into 5 equal parts. 1, 2, 3, 4 and 5. So each wire resistance will be R by 5, R by 5, R by 5, R by 5, R by 5. Now we are going to compare each part of the wire change compare with the original resistance. So let us take R1 is original resistance, R by 5 is changed resistance. The ratio is, question is, how will the resistance of each part of the wire change compare with the original resistance? So each part of the wire resistance is R by 5, that one take R2 with the original resistance by R1 is equal to R12 is R by 5 divided R. So R2 by R1 is equal to R by 5 int, it is going to be reciprocal 1 by R. So R are going to be cancelled. So R2 is to R1 is equal to 1 is to 5. This is a sub question 4b. If the 5 parts of the wire are placed in parallel, how will the resistance of the combination change? These 5 parts going to be connected in parallel, then effective resistance we are going to find out. The parallel connection nothing but more than one component connected between the same points. For example, A, B. This is common points. Between these common points, we are going to connect the more than one component. Here there are 5 components are there. So we are going to connect one by one in parallel. Each value resistance is R by 5, R by 5, R by 5, R by 5, R by 5. All are connected in parallel according to that question. Now effective resistance formula in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. This one R by 5 is R1, R2, R3, R4, R5. So all are equal. So 1 by Rp is equal to 1 by R1 is R by 5 plus 1 by 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 R by 5. Denominators are same. We can add the numerators. So 1, 2, 3, 4, 5. So 5 by R. This by 5 will go to numerator into 5. So take reciprocal both the sides. Rp is equal to R by 25. This is effective resistance in parallel circuit when each parts of the wire connected in the parallel. This is another method. Alter. If resistances are equal in parallel circuit, the effective resistance is Rp is equal to R by N. Rp is equal to where R resistance of each part. So here R by 5. N is the number of resistors. So there are 5 resistors into 5. So Rp is equal to R by 25. This is another method to solve this one. Last sub question 4C. What will be the ratio of effective resistance in series connection to that of the parallel combination? Already we know that in parallel circuit the effective resistance is Rp is equal to R by 25, but we don't know series combination effective resistance Rs, but we know that formula Rs is equal to NR. N is a number of resistors having the equal resistance. So R is a resistance of a resistor of small part. So here each resistor having the resistance value is R by 5. So how many resistance like this? 5 equal parts. So 5 resistance are there. So Rs is equal to N is 5. Then R resistance of one resistor is R by 5. So this 5 going to be cancelled. Now effective resistance series is equal to R. According to that question, we are going to find the ratio of effective resistance series combination to the parallel combination. So Rs by Rp is equal to Rs value is R, Rp value is R by 25. R by 25, the 25 will go to numerator. R are going to be cancelled. So Rs is Rp is equal to 25 is 1. This is the answer for 4th C. Next hard questions. The hard question first one. Two resistors when connected in parallel give the resultant resistance of 2 ohm. The resultant resistance is 2 ohm in parallel circuit. So take it as Rp. But when connected in series, the effective resistance becomes 9 ohm. In series circuit, the effective resistance is 9 ohm. Calculate the value of each resistance. So how many resistors? 2 resistors. So we have to find out R1 value and R2 value. When both are connected in parallel, the effective resistance is 2 ohm. We know that parallel circuit effective resistance formula Rp is equal to R1 into R2 divided by R1 plus R2. So we know that 1 by R1 plus 1 by R2. Instead of that, we can write in this simplified method, product in numerator, addition in denominator. Then series circuit, Rs is equal to R1 plus R2. Now we can substitute the values. For series circuit, the effective is 9 ohm. So 9 is equal to R1 plus R2. For our convenience, we can find out R1 or R2 in this formula. So let it be equation 1. Now R2 is equal to, so R1 came here means 9 minus R1. This let it be equation 2. Now come to this parallel circuit equation. Rp value is 2 ohm. So substitute here 2 is equal to R1. Then R2. For this R2, substitute this value 9 minus R1 divided by this R1 plus R2. We know that 9. So here we used equation 2. Here we used equation 1. Now we can simplify. 9 2s are 18 is equal to 9 R1 R1 into R1 R1 square here plus into minus minus. Then both of these terms take left hand side. So R1 square plus minus 9 R1 is plus 18 equal to 0. This is like quadratic equation. This quadratic equation you can get the roots. So 18 6 3s are 18 here minus 9 is there, so minus 6 minus 3. Now R1 minus 6, then R1 minus 3 is equal to 0. R1 minus 6 is equal to 0, or R1 minus 3 is equal to 0. R1 is equal to 6 ohm, or R1 is equal to 3 ohm. If R1 is equal to 6 ohm, if R1 is equal to 6 ohm in equation 1. So in this equation, in equation 1, 9 is equal to, this is so for equation 1, 9 is equal to R1 value, R1 is 6 plus R2. Now 9 minus 6 is 3, so R2 is 3 ohm. If R1 is equal to 3 ohm, if R1 is equal to 3 ohm in equation 1, so in this equation, so in this equation if we substitute 3 for R1, we'll get R2 value 6. So 9 is equal to R1 is 3 plus R2. 9 minus 3 is 6 ohm. This is R2. So there are two possibilities. If R1 is equal to 6 ohm, R2 is equal to 3 ohm. If R1 is equal to 3 ohm, then R2 is equal to 6 ohm. Two possibilities. This is answer for first one. Question number 2. How many electrons are passing per second in a circuit in which there is a current of 5 ampere? They are asking the number of electrons. To find the number of electrons, we can use the quantization condition of charge. Q is equal to Ne, where N is the number of electrons, Q is a charge, E is a charge of an electron. So Q by E. Now charge of electron, already you know that 1.6 into 10 power minus 19. So E is equal to 1.6 into 10 power minus 19 coulomb. This is constant value, we should know this. Then Q. So we need Q, but in the question they given I. So how will you find out? From this formula Q is equal to IT, we can find the charge. So Q is equal to I is 5, then time here 1 second. So per second the given here in question. So T is equal to 1 second, so T is equal to 1, then Q is equal to 5. So N is equal to Q value is 5, and E value is 1.6 into 10 power minus 19. The 10 power minus 19 will go to numerator. N is equal to 5 by 1.6 into 10 power plus 19. If you simplify this, number of electron to produce a 5 ampere current in the circuit will be 31.25 in 10 power 18 electrons. Part question number 3. A piece of wire of resistance 10 ohm is drawn out so that its length is increased to 3 times its original length. Calculate the new resistance. A piece of wire of resistance is 10 ohm, so you can take it as R. Is drawn out that its length is increased to 3 times its original length. So the new length will be 3 times its original length. Calculate the new resistance. So R dash, this new resistance we have to find out. Already we know that resistance is directly proportional to length of the conductor. If the length is increases, resistance also going to be increases. So a change in the length, so there will be a change in the resistance, that is mentioned here, new resistance. R is equal to rho L by A. Resistance of wire before drawing into 3 times is 10 ohm. If that wire drawn into thrice times its original length, R dash is equal to rho L dash by A dash. If there is a change in the length 3 times, automatically change in the area of cross section of the wire. So if the length is increased 3 times, the thickness of the wire going to be decreased. So your length is increased 3 times, so the thickness will be decreased 3 times. So A dash will be A by 3. This is hidden in the question. So we should know if the length is increased 3 times, automatically area will be decreased by 3 times. Now you can substitute in this formula. R dash is equal to rho L dash by A dash. So rho L dash is 3L, then A dash is A by 3. So 3 will go to numerator, 3 these are 9. 9 rho L by A. This rho L by A value is 10. So 9 into 10. So the new resistance is 90 ohm. R dash is equal to 90 ohm. So if the length of the wire drawn into 3 times its original length, its resistance becomes 90 ohm. So 9 times increases. Thank you, students.